How y'all doing? Nah. Nah. It's the last day of the conference. There's a train strike. Lunch was awful. I haven't had my nap yet. All of the above. Okay. Just out of curiosity, how many people are here to expect a bit of a takedown of the whole concept of quick and dirty? How many here, just actually before I do that, how many people here self-identify as a software craftsman? No hands. One hand in the back where nobody can see them. Okay, interesting. How many people here care about the quality of the stuff that they churn out? Okay, fair number of hands. That's interesting. How many people here presented with the chance to do it quick and dirty versus the chance to do it right would choose to do it the quick and dirty way? A lot fewer hands. There are a few who are like, yep, that's me. Yep. I'll be curious to hear your thoughts on that particular question in a little bit, because, generally, for the most part, when we talk about the concept of quick and dirty, we generally agree it's bad. You start spending any amount of time in the literature, right? 10 years from now, if you are doing something quick and dirty, you suddenly visualize that I am looking over your shoulders and say to yourself, Dijkstra would not have liked this. That would be enough immortality for me. Okay, folks, if you're writing code and you feel a ghost peering over your shoulder, criticizing your code, you probably have bigger problems than the code. Just saying, maybe you need an exorcist, or I don't know. Maybe you need to leave like an offering of some structured programming on the doorstep. Not quite sure. Doing things the quick and dirty way sets us up with technical debt, which is similar to financial debt. How many people here love being in debt? Nobody? Am I the only one? There's like one person like, I feel bad for you. So I'm just going to raise my hand like halfway where nobody behind me can see it. Yeah, financial debt incurs interest payments, come in the form of extra effort that we have to do future development because of the quick and dirty design choice. We can choose to continue paying the interest, or we can pay down the principal. Martin Fowler, and he's not even a ghost. So if Fowler doesn't like it, and Edgar Dijkstra doesn't like it, throwaway code. This is actually a pattern description by Foote and Yoder, who were very popular during the height of the patterns movement. They wrote a number of what we would today consider the anti-patterns, things that you would prefer not to do, right? So throwaway code is one such pattern. The big ball of mud is another such anti-pattern, right? That code that just kind of oozes everywhere, that really, really ugly monolith that you even look at and you get stuck in, you get mired in, et cetera, et cetera. Quick and dirty code was intended to be used only once and then discarded. Such code often takes on a life of its own, despite casual structure and poor non-existent documentation. What do they mean by that? You all know it. Even if you've never experienced it, you all know it. Because programmers are connected. There is this energy field which binds us all and connects us all, right? We learned about it in the movies. It's called the source. And the source, a Jedi knows how to tap into the source, but more importantly, as we saw demonstrated in that episode entitled A New Hope, when something terrible and tragic and awful happens, we can all feel it. We all know it. Wait. I feel it. I feel a disturbance in the source. Somewhere there is a programmer who has been approached by their boss. Yes, it's their boss. And their boss says, I need you to create for me a quick prototype. Just a quick and dirty application. The guys in marketing need something to make sure that we could do it. And the programmer, the poor fool, has agreed to do it. And the programmer spends about a week or so downloading various things, various tools, various libraries, scaffolds something out. There's a bunch of really fake data in a number of places. There's for God's sakes, he didn't even use Kubernetes. And he shows it to the marketing people, and the marketing people, they love it. They think it's amazing. And then now the programmer suddenly realizes the disaster that is about to befall him as the manager looks at the programmer and says, ship it. And like an action star in slow motion, the programmer, but it's too late because now it's going into production. And now that programmer will be doomed to work on that quick and dirty code for the rest of their natural lives, unless they somehow manage to escape the country and go to London and give a talk. I may not be allowed back in, we'll see. How many of you have lived that? See, surprisingly, one hand in the back, two hands, one up here in front. Surprisingly, very few of us have ever lived it, but we all know what it's like. We've heard the stories. We've felt the pain through the source. And so I think it's fairly safe to say that everybody agrees quick and dirty is bad. So we're done here, right? There's nothing else to talk about. It's bad, it's terrible. Who would voluntarily sign up for what I just described? Except, you knew there was an except, right? We don't always seem to agree that it's bad. One of the things that often comes up, and just to give you a bit of the genesis, this keynote I was asked to create, this presentation I was asked to create as a keynote for a conference for an acquaintance of mine. And specifically, it was the first run of their particular conference. And he said, we're trying to put this thing together with, little in the way of planning. We're throwing it together in a couple of months. Can you do something around the topic of quick and dirty? I'm like, yeah, absolutely. I can, and I figure I'll walk into this and I'll just start, hammering on all the ways this is terrible, don't do it. And we move on. But when you start doing some of the research, right, you start with a Google search and you look at the phrase quick and dirty, you start to realize a lot of people actually have a very different impression of this phrase. We often see quick and dirty, the quick and dirty guide to something as kind of an introduction, a tutorial, or in some cases it's a short synopsis. If you go to the Urban Dictionary, I don't want to tell you what you're going to find. Okay, that this is a family-friendly conference, and I would like to come back here at some point. But it's very clear that we don't all of us, even within the programmer community, we don't all of us consider the idea of quick and dirty to be bad. There is a very vocal group of people, particularly the software craftsmanship movement, that absolutely wants to set up outside and conduct their own strike in front of this presentation, because to them, this is anathema. This is absolutely the opposite of everything that they stand for. When you sign your name to your code and you are a craftsman and you are proud of your craft, they keep using the word craft over and over and over again, almost like if we say it often enough, it will just magically get better. Kind of like Brexit. It's very weird how that turns out that way. So let's take a moment and let's re-examine what we mean by all of this. Everybody's pretty clear on the concept of quick, right? And definitely, I think everybody can be pretty confident that, quick is better than slow. I mean, if you have a choice around anything, you would generally prefer it to be faster, so long as we're not making too much in the way of trade-offs, right? If you take your car into the service station to be fixed, they say, well, we can do it the quick way and have it done in an hour, or we can do it the slow way and have it done in a day. And you say, okay, what's the difference? And they say, the number of breaks we take during the day, I guess. You'll opt for the quick version. Generally, We often, our time is precious. It's the most precious resource we have because we can never get more of it, blah, 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 blah. Everybody's pretty comfortable with quick. It's the dirty part because that's usually the perceived trade-off. Dirty is bad. Dirty means we're going to incur all of this. Again, we go back to Martin Fowler's analogy here. Dirty suggests that we're taking shortcuts in the code, that we are not, in fact, providing quite as much discipline. We're not, in fact, providing quite as much structure, or perhaps we're not thinking through all of the possible edge cases and so forth. So dirty here means that, we are going to incur these interest payments come in the form of extra effort that we have to do in future development. That's generally the perception of dirty here. The thing of it is, this quote isn't quite complete. People have made a considered decision to adopt a design strategy that isn't sustainable in the longer term, but yields a short-term benefit, such as making a release. The point is that the debt yields value sooner, but needs to be paid off as soon as possible. How many people in this room have ever purchased an automobile, a vehicle? Show of hands? Fair number of you, sure. And you walked in and paid for it with cash, right? One hand. That's bravery right there. By the way, congratulations on your fiscal discipline. That woman is my new CFO. Just saying right now. The rest of us, no, not so much. What did we do? We walked up to the dealership and we took out a loan. We incurred debt. Now, we just agreed, all of us, that debt is bad. If you've ever purchased a home or a condo or any other sort of real estate property, I almost guarantee not even she was able to do it in cash. Especially nowhere here in London. Unless maybe you're one of Trump's spawn or something, I don't know. We often take out debt because it serves our purpose. Because in fact, if we were to try to, through our normal day-to-day living, if we were to try to save up the available capital in order to be able to purchase something without taking out a loan, in many cases, it would take substantially longer. And in many, many cases, that debt, the money that we get from taking out that debt, can be used to generate things which could actually create more capital for us down the road. This is the whole point of, for example, seed funding or Series A, Series B funding, right? They are giving you money, you're incurring an obligation to them in turn because there is a belief that this will generate more money, that this will in fact create benefit down the road. You obviously need to pay off that debt as soon as possible. Why? Well, because interest. As time goes by, the price of using that money will begin to accrue. The debt metaphor reminds us the choices we can make with design flaws. We can deliberately choose to make some decisions. We can deliberately choose to write code in a particular way, to willingly accept that there are potentially better ways to deal with this at some point down the road, but it would take more time and energy to build with it now. The useful distinction isn't between debt or non-debt, but between prudent and reckless debt. If you were to come up to me and say, hey, Ted, I could use a little financial advice. I'm thinking about taking out a loan for £1 million to go buy a property here in London that I'm going to turn around and sell in a few years, or I'm going to use to open a business here in town, or I'd say that seems relatively prudent as long as your financial models and business models seem to make sense. If you come to me and say, hey, Ted, I'm going to take out a loan of £1 million in order to buy Bored Ape NFTs, you're reckless. That's not a good choice. And if you were to say, I'm going to take out £1 million in order to invest in Beanie Babies. Does anybody still remember the Beanie Babies craze? Back in the 80s and 90s, there were these stuffed animals called Beanie Babies. And there were people who actually took out bank loans in order to amass a Beanie Baby collection because it'll be worth millions. They said the same thing about Pokemon cards. Not that we still have thousands of dollars of Pokemon cards sitting in a cabinet somewhere. Prudent versus reckless debt. Deliberate versus inadvertent debt. These actually form a two-axis graph to give us an interesting choice of four different possibilities here. The deliberate reckless debt is often the one that we think about when we think about the whole notion of quick and dirty. We don't have the time to actually design this, quote unquote, the right way. We don't have time to think about all of the different possibilities. We don't have time to shoot out which JavaScript framework we should use. We don't have time to benchmark which of the cloud providers gives us the best performance to scalability ratio. We don't have the time because we've got to get something done like by the end of the week. There is the inadvertent reckless debt, which can best be summed up by interns. How many of you have ever worked with somebody who is fresh from university? Isn't it amazing that these people have not died yet? There is so much they don't know. I mean, how did they ever reach the point of adulthood without knowing about layering in an architectural distributed system so as to be able to successfully segregate different parts of that? How do they not understand that when you issue a relational query, you actually want to fetch more of the data in one go rather than making hops back and forth across the network? How can they be so stupid? Because they don't know any better. And surprise, surprise, so were you once. And most of us know that. Most of us accept that. And that's why we're often very, very forgiving of the intern when they do things. But surprise, though it may be to all of you, you're still stupid. You just don't know what you're stupid about. Which, if you think about it, is even stupider. Fortunately, you're here. That's the whole point of coming to a place like this, is to figure out what you're stupid about so that you can learn a little bit about it, then do more study later. But until you have managed to basically change your stupidity, you are inadvertently reckless because you don't realize that there are better ways to develop this database than by trying to do a graph in a relational database model, for example. There is the deliberate prudent debt, and this is where much of the good stories come from when we start talking about quick and dirty. We understand we're taking shortcuts. We absolutely know that there are better ways to do this, but we in fact have a series of additional forces upon the context in which we are talking about that require us, or that we choose to make the decision to ship this thing now rather than later. And we'll talk a little bit about some of what those forces might be. The inadvertent prudent actually is often what programmers feel after they've shipped V1 of something. Okay? In many respects, we made some design decisions. We didn't exactly know why, but we did. And then when we came back around, we realized, oh, that's what we should have done. Now we see it. Now we get it. The useful distinction isn't between debt or non-debt, but between prudent and reckless. Which are you being in a given moment? That's really the crux of the question, isn't it? It's not about whether or not we're incurring the debt. It's whether or not the debt is worth the trade-off. It's whether or not the debt is, in fact, going to pay off in some way. If you take out that £1 million loan, you're going to use the money in order to be able to create some additional home remodeling around the property in order to be able to sell the property for 2 or 3 times what it once was, which will then net you a profit. During that time frame, of course, you have to make payments. And if you don't flip the property fairly quickly, the payments will eventually overwhelm whatever profit you might generate. This is when you're, quote unquote, underwater on the property. Same thing with code, same thing with software and architecture and all these other things. Do you have a plan for paying it off? We'll get to it someday is not a plan. I'm sorry, it's not. That may be all the plan that we have at this exact moment, but then the first step of the plan is once we get to this release, now we go back, we figure out all of the debt that we have incurred, and we start planning for how we're going to correct for it. If you are working at a company and you are not completely building something blue sky, that is to say, if you're not completely building something brand new and just feature filled, etc., if you've got any kind of maintenance that needs to be done, if you've ever shipped anything before now, you need to allocate some time out of each sprint to be able to go back and pay down that debt. If you have 5 projects that your team was responsible for, then you'd better have 5 interest payments somewhere in your sprint. And it starts to get to a point where a team starts looking at the available bandwidth they have and realize new features will only comprise maybe 10 to 15% of the total amount of time spent during a sprint, because the interest payments on all those projects have so steadily accrued. And that, folks, is when people like to declare technical bankruptcy. They say, we can't support this project anymore. The team is underwater. We need to just throw it all away and start over. Or we need to just freeze it and admit that we're not going to make any more changes to this and we're done. We need to, or ideally, the positive way to do this is we need to hire more developers. We need to create a new team. We need to actually create some additional bandwidth to support all of these interest payments, because we can't just turn these systems off and keep going. It'll depend entirely on the situation that you're in, but you better have a plan. I don't care what the plan is, but somebody had better be able to walk up to you and say, what is your plan for paying off the debt? And if you don't know, particularly if you're the leader of the team, the manager of the organization, if you don't know an answer to that question, you are running a huge risk. Throwaway code, quick and dirty code, intended to be used only once and then discarded. This is a real danger. Don't ever lose sight of this paragraph. Whenever you do something, regardless of how much time and energy you put into it, regardless of how much planning you put into it, remember, there is a lot of that debt that is inadvertent debt, inadvertently reckless, because we didn't know what we were doing until after we built the first one. And trying to figure all of that out up front will take a tremendous amount of time. And even then, there's no guarantee that you will have it completely figured out. There will always be some inadvertent debt that is incurred on every project, because by definition, software development is bespoke. You're generally, 98% of the time, not building something that hasn't been built before. So keep that in mind. As a matter of fact, maybe this is a good thing. A couple of years ago, if I remember correctly, D-Zone, one of the developer portals, ran an article. Is this the age of the throwaway software system? Just out of curiosity, another poll of the audience, how many people here have worked on a software system that is more than 5 years old? Show of hands. Okay, good, most of the crowd. Older than 10 years. Okay, fair number. Older than 20 years. Well, now we're starting to drop off a cliff. How about 30 years? 40 years? 50 years? 100 years? Did you write COBOL code back in the day?
Not back in the day, but interfaced with mainframe systems.
You interfaced with mainframe systems. Okay. All right. So you're the one. Seriously, most of the financial institution continues to run on COBOL code, much of which was written 60 years ago. I once was teaching a training class on C# and had a gentleman there from NASA. And I mean, he was the quintessential NASA engineer. He had a pocket protector out to about here, and it was stuffed with pens and pencils, some of which I don't think had actually been removed from the protector in 30 years, right? And he had these glasses which were constantly askew and kind of off one ear. And dude had been writing code since 1953. And I was just like, oh shit. I kind of feel like I should like genuflect or something. I mean, there are a number of people that I run across who've been writing code since before I was born, but damn, that's a long time before I was born. How many of those systems are still around? How much of the code, if you were writing code 40 years ago, how much of the code that you wrote is still in existence? This is the thing that the COBOL people have over us, right? For all that, the Java developers and the .NET developers and the Ruby and the Python developers, they look at COBOL, they point and they laugh. Ha ha, you work on legacy code, you suck. And then those COBOL programmers, who by the way are probably making more than any two of us combined, they watch as you take your check and deposit it at the bank, which then runs through their COBOL programs that have been running for 65 years. Most software systems that we build today probably have a shelf life between 10 or 15 years, depending upon how loose or how strict we are with the definition of the word system. Time to market is all that matters. How fast can I get it? Does it work? How much does it cost? I live in Seattle, Washington, which is where a lot of these startups are coming from. And if you've ever done anything in the startup community, you hear this phrase all the time to market. How quickly can we get it up and running? How quickly can we get it out there? How quickly can we get people using our stuff? Is this the age of throwaway software systems? Because systems are no longer targeted to be long-lived. For a lot of the startup community, they actually go in and create a business model. They create a plan with the full intent of being acquired by somebody else within, say, a span of 5 years. If they haven't been acquired by the fifth year of the business's existence, they kind of consider it a failure because they just kind of want to flip the house. They don't really want to live in it. And so all we need is for the software to get us far enough to get the house flipped, to get the startup sold, to get the startup acquired so that we can then start the next startup. We're not interested in building systems that will last 25, 30, 40 years. As a matter of fact, I would challenge that if there were any Java code that was written back in 1997, if you tried to run it today, I think you would run into a lot of problems. I mean, does anybody even know how to run an applet anymore? How about Swing? Anybody here ever actually seen Java Swing in the wild? Couple of hands. No, we're not going to close that app. Thank you very much, though. The other thing is, how many of you consider yourselves to be agile practitioners? What does agile tell us? Agile tells us frequently that we don't wait for people to have a complete understanding. We don't wait for this 3-ring binder chock full of requirements documents. Agile tells us, and as a matter of fact, particularly if you look at Agile's older cousin, which is to say extreme programming, it tells us that trying to write all that stuff down is in fact a waste of time. Let's just have an on-site customer, to use the XP term, or a product owner, to use the more modern version of that. And they are our subject matter expert, and so we ask them those hard questions. So in many cases, it is by definition that if you are following an agile methodology, big A or little a agile, you are writing code without knowing the complete picture. You are by definition going at this with incomplete understanding of the problem domain. That's not a terrible thing. I don't need to understand everything. I need to understand a few things about the part that I'm working on, because deeper understanding will come later. But it still means that periodically we have to come at this with a best guess. I'm not quite sure how this is supposed to work. My on-site customer is currently in a meeting. My product owner is currently out for a week, whatever. I'll just take a crack at it and make a note, and we'll have a conversation about it later. And what if we're wrong? See, one of the interesting things about Agile is Agile said we want to do all of these little short iterations so that we can check in with the customer on a repeated basis. That's the whole point of that delivery ceremony, right? When you actually get to the end of the sprint and you bring the customer in and you do your sprint demo, have you ever had the customer say no? I mean, that's theoretically what's allowable to happen here. The customer could look at that and say, that's not actually what we want. And part of the reason we do these in short iteration cycles, again, if you follow the agile processes, methodologies, etc., part of the reason we do these short iteration cycles is because if the customer says, no, I don't actually want that, we only throw away one sprint's worth of work. Now, just out of curiosity, how many of you felt the hairs on the back of your neck rise a little bit when I say throw away the sprint of work? If you've never thrown away a sprint's worth of work, chances are you're probably not as agile anywhere as much as you think you are. Because agile frequently encourages us to embrace change, and change often means backing up and starting over. Oops. Hello. There we go. Ink. When we work on something, we pay careful attention to the details, take the time to polish every little thing until it's just right. As a result, 37 Signals. You guys know who that is, right? David Hannemeyer Hansen's company. They make Basecamp, a couple other things. DHH, of course, is very well known in the Ruby community as the guy who invented Rails. 37 Signals is known for focus on quality. We take that reputation very seriously. It turns out that's a problem. Began exploring an idea for a new product. 6 weeks, we sketched out some ideas. You can kind of see this playing out like a little video montage in your head, right? Got a little fast beat rock music and dun 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 dun. You can see these guys at whiteboards and they're sketching things out. They're making some suggestions. A week later, we had almost nothing to show for our effort. Nearly 2 months had passed. We still had no idea if it would work. What happened was we forgot we were just building a quick and dirty demo for ourselves. Obsessing about quality too early in the creative process prevents a lot of good ideas from taking shape. Ever been in a brainstorm? An actual proper brainstorm? Where you get a group of people into a room and you're trying to throw a whole bunch of creative ideas out to see if you can figure out what steps to take, what direction to take, how we could perhaps creatively troubleshoot this problem that's bothering us. What's the first rule of a brainstorm? There are no bad ideas. Do not filter what's going through your head. The idea is to get it out of your head, get it out onto a board, let other people riff on it. There are no bad ideas. Don't filter. Don't try to apply some kind of quality. You don't have to have a fully fleshed solution. We're all here together to try to come up with one, et cetera, et cetera, et cetera. They forgot. Because there was that emphasis, that obsession over quality, they stopped a lot of these ideas from taking shape and even seeing if it could fly. As businesses grow, all sorts of things that were once done on the fly have a way of becoming bureaucratized. Doubts, deadlines, resource planning, all of this stuff is essential, but only later on. Fretting about such matters at the outset only gets in the way. I see startups overthinking simple problems, adding too much structure too early, trying to get too formal too soon. Embrace their scrappiness. Now you say to yourself, okay, this is all great, Ted. You live in Seattle. You hang out with startups. I don't. I work for insert big company name here. And we are the last thing from scrappy that you could ever possibly imagine. The company might be, but your team doesn't have to be. Your team can be scrappy. Your department can be scrappy. Microsoft is arguably one of the largest software companies in the world, been around since the very earliest days of computing, and yet many of the organizations within Microsoft, for example, the Patterns and Practices Group, carved out their own space and carved out their own ways of doing things long, long before other companies created innovation teams. Because particularly with a strong manager and particularly with a clear goal, clear guide, You can say, if we want to start doing a bunch of things in a quick and dirty fashion, we can incur that debt because it's all part of our larger plan. The ability to run with scissors is a blessing, not a curse. Minimum viable product, MVP. How many of you have heard that acronym before? What a lot of times people take it to mean is basically, I'm just going to do the first slice of a particular thing, and we'll just keep doing more slices until we're finished. LinkedIn has had a number of these interesting graphics where a minimum viable product for an automobile is not the pair of headlights and a grill. The minimum viable pair for an automobile is often a bicycle. And then maybe we go to a powered bicycle. Then maybe we go to a motorcycle, and then maybe we go to a quad, ATV, as we call them in the States, and then maybe we put a cabin around it, and lo and behold, we have an automobile. That's a much more realistic MVP, because the whole goal is to build the smallest set of features that still allows a customer to, most often, purchase a thing, purchase a good, purchase a service, do a something by which you will make some money. And the thing that we keep stressing in the startup community is it doesn't actually have to be a software system. If the goal of your company is to sell a blank, well, then get out on the street and talk to a random stranger and try to sell the blank. That's the minimum viable product, not the website that's used. If you're Spotify and you're trying to come up with ways to make music stream over a system, start by trying to figure out how to use iTunes as a database and make that data available over the internet so that people could stream your iTunes library. Get your first customer, then get your 10th customer, then get your 100th customer, and by that point, you probably have a good idea as to what it is you're actually trying to build. As opposed to, we're going to build the Spotify website with all the various edge servers, and we're going to make it Google scale. Google scale, to my mind, that phrase has become a red flag for people who are absolutely coming at it the wrong way. I don't care about Google scale until I'm Google. What I care about is, can I get it out the door? Can I get it into people's hands so that they can work with it? In other words, what I am frequently telling you to do is to follow a fairly simple flowchart. Set a hypothesis, regardless of what it is. The hypothesis may be that I believe that if we build this, people will come and purchase it. Or it may be that we want to figure out a different way of marketing to people, or what have you. You set some kind of hypothesis, you write it down, you build something that's used to prove or disprove the hypothesis. Case in point, many of you will have spent some time out here amongst the vendor booths, and unless you are a particularly unique individual, there is likely something out there that you've never seen before. You've never played with it before, you've never downloaded it or run it, and maybe it will solve a particular problem for your company. I will use as an example perhaps an enterprise framework that will allow you to be able to better access data to and from a database. And you go back to your boss and you say, I think this could be interesting, and your boss says, great, build a prototype. Okay, I can do that, not a problem. Most of the time, when people build a prototype, what do? They say, well, let me start from the demo that the company has built, and let me maybe throw a few things into the database of our domain, and oh, look, it still works. Yay, prototype successful. No, it's absolutely not successful. What you have proven is that the company has created a successful demo. What is the hardest problem that your company faces? What is the hardest part of your database for any of these systems to be able, if you're looking at object relational mapping tools, for example, or if you're looking at streaming tools, and you actually have 17 meg files filled with binary data that need to be shipped across a Kafka stream, that's what you prototype. That's what you throw at this thing. You literally want to see if Kafka can handle the worst kinds of traffic that you can throw at it, not the easiest. That's what makes a successful prototype. And then once you've proven that, you delete it. I cannot emphasize this enough. Go up to GitHub or go to wherever you're storing this repository and delete it. Because if you don't, somebody will get the bright idea that we can maybe take this and use this as the spine for the final product. And you don't want that. Nobody wants that. Except maybe Emperor Palpatine. Let's go back to iterations here for just a second. Why does Agile suggest iterations? Responding to change, working software. We want to get software working bits as quickly as possible. Simplicity, maximizing the amount of work not done is essential. This is why we want to take things in short stints. Think about this. This is how you drive anywhere. When you are driving behind the wheel of a car, you're not planning your entire route out with all of the turns and whatnot. You're engaging in a rapid feedback loop. You're watching the street in front of you, and then periodically you get a direction either from your GPS or, in my case, from the GPS labeled spouse that says, turn here, turn there, take this roundabout, etc. But in each case, these are all a series of short iterations because that allows me to react to whatever the conditions are right in front of me. Because if, in fact, a bus pulls out, I don't want to just keep going in order to turn right. I need to slow down, et cetera, et cetera. We need to respond to all of these things as they come up. An iterative process is one that makes progress through successive refinement. Take a first cut at a system, knowing it is incomplete or weak. Mike buries this inside of this definition of iterative. You know when you begin work on a system that you're going to get parts of it wrong. Now, many of us, perhaps the more naive in the crowd, believe that there is a subject matter expert who is a part of this project who will prevent us from getting it too badly wrong. Until you find out that they're not perfect and they can get things wrong. They can forget things. They may not have the perspective on the particular area of the system, et cetera, et cetera. Embrace the wrongness. Wake up in the morning, look in the mirror, and say, I will be wrong today. It's actually quite liberating. It really is. I will fuck something up today. I know it because I'm human, because that's the way we are. With each iteration, the software is improved through the addition of greater detail. See, that's part of the whole point of the iterations. Every time we go through it, we correct a little thing. We pay off a little bit of that debt. The funny thing is, the Agile community was not the first community to really embrace this notion of iterations and successive refinement. How many have heard of the OODA loop? One hand. 1.5 hands. Observe, orient, decide, act. A gentleman by the name of John Boyd, United States Air Force back in the day, flew in the Korean War, known as 60-second Boyd, is able to get on the six, that is to say, get behind any opposing pilot, either in combat or in trials, within 60 seconds. He had a very, very intuitive understanding of the physics of air combat and the physics of flight and so forth. So after he finished his tour of duty in the skies, he turned his hand towards trying to create better aircraft for the United States Air Force. And in many respects, he was very successful because 3 of the aircraft that bear his distinct style are the F-16 Falcon, which is in common use through a lot of the NATO countries in the West here, the F-15 Eagle, which is one of the few aircraft to literally never be shot down in combat, and the A-10 Warthog, which is just the most bizarre aircraft you'll ever see because it was designed from the get-go to be a close ground support aircraft. It's literally built around the largest Gatling cannon you can see. We hang a bunch of missiles from it. We put the engines high and in the back so it's harder to see, and we put the pilot in literally a titanium tub to keep him alive from any ground fire that might come up. Boyd helped design all of those aircraft. As he began his studies of aircraft design, he realized that pilots, particularly during air combat, but during any sort of combat, air to air to ground, what have you, go through this cycle where we observe, we get some information about the situation we're in, we're orient. We decide what that information means. I'm currently flying at 37,000 feet. I see something off in the distance. I have a wingman. All of this information orients so that I can now make a decision as to what it is I want to do. And then, of course, I carry out that action. And that action will yield some kind of response, typically from the opposing pilot, which will then give me some more information, which will then lead to another decision, which will then lead me to do something, et cetera, et cetera, et cetera. You can see how this becomes a loop. And we all say, well, of course, iterations. We understand iterations. The thing is, the fundamental, unavoidable, all-pervasive presence of uncertainty is the starting point. We don't know what we don't know. I don't know what that other pilot is going to do. And I have to be able to observe their actions and form some kind of model as to what they will do, change those concepts as reality itself appears to change. By the way, is this starting to sound kind of familiar to what we do on most projects? As we start working on it, we start getting a better sense of what the requirements are, et cetera, et cetera. And what many of the OODA practitioners learned is that this applies just as much to science as it does to air combat. Frequently, we discover something not because a scientist wakes up in the middle of the night and has a brilliant revelation, but because a scientist looks at some data on their laptop and goes, that's funny. Literally, those are the words that often yield the biggest scientific breakthroughs. Boyd's stated aim was not to just do the OODA loop, but to get inside his opponent's loop. In order to win, we should operate at a faster tempo or rhythm than our adversaries, or better yet, get inside the adversary's OODA time cycle or loop. If you are running a business and it takes you 12 months to finish a project, and I'm running a business and it takes me 6, I will win every time. Every time. Because if you come out with a new feature after 12 months, I can replicate that feature within 6, and then I can come up with an extension to that feature, which will now take you 12 more months to catch up to. This is the true nature of innovation. But you have to be able to get through that cycle faster. You have to be able to move through that loop at a faster pace, the tempo and speed with which the loop executes. We need feedback. This is the whole heart of everything Agile, by the way, is feedback. Why do we do unit tests? To get feedback on the state of our code. Why do we have the customer on site? Because that way they give us feedback on the decisions we make. Literally 85 to 90% of all the things that we classify as Agile is about an attempt to close the timing of this loop so that we get that feedback faster. This is why people will frequently say that dynamic interpreted languages like Python and Ruby are better to program in than languages like C# and Java, because we get the feedback faster because I just write it and hit return and boom, it runs or it doesn't. As opposed to waiting for this long slog of a compile cycle, et cetera, et cetera. The sooner we can get feedback, the better we can get feedback, the sooner we can make these changes, the tighter our OODA loop becomes. And you can't get feedback without something there, without something running, without something that's generating that feedback. Go back to the quote from 37 Signals. Startups should embrace their scrappiness. The ability to run with scissors is a blessing. Build something. Just go build something. I don't care if it's perfect. I don't care if it scales. I don't care if it has all the features. Build something. Get it out into people's hands so that they can start to give you that feedback that will help you then decide what the next iteration of your OODA loop will look like. And remember that when you get to a particular point, stop. One of the hardest things to do in software right now is stop. How many features does a word processing program have to have anyway? Just how many features does a spreadsheet have to have? Why do we still get new versions of Word and Excel every couple of years or every couple of days now that it's all cloud? I mean, email clients. I mean, chat systems. How many new chat systems do we need to have? Because first there was like Internet Relay Chat, and then there was Microsoft Messenger and AOL Online Chat, and then, well, now it's Slack. I mean, Discord. I mean, Teams. I mean, how many of these do we really need? At the end of the day, all I want to do is open a socket and send you a sentence. The end. Yeah. Get off of my lawn. What does this mean? Quick and dirty is often thought of poorly. We often talk about it in very, very negative terms. But a lot of that has more to do with our ego. We don't want to be the ones responsible for that crappy code that somebody else inherits, because we all have pride. We all have pride in the things that we do and the work that we turn in. Because to us, pride stems from the beauty of the thing we built and not from the value that we brought to the customer. And that's kind of telling, isn't it? If I can build something that is completely scrapped together with duct tape and spare parts, and it's the most amazing thing, and it's perfectly exactly what the customer needed, haven't I won? Don't I get to count that in the W column, even if it's not beautiful and 100% unit test code coverage and using the latest programming language? I mean, God help us if I build the next startup in COBOL and it actually makes money. When do we abandon this? Has the problem lasted longer than we thought? Does it have more angles to it than we thought? Are we keeping the system around for 5 years? These are all reasonable decision points. And lastly, let me be very, very clear. This is a tool in your toolbox. This is something for you to consider as you build your next system. It is not the one and only way. I am not trying to get you to abandon all planning and just start hacking shit together. That's not what I'm saying. But there are times when the goals of the project are such that hacking shit together is exactly the right thing to do. Peace out.